Well, hello scrappers, Mike here. Welcome back to my channel. Yes, I know it's been a while since I posted a video. I have been out west for the last month on our usual spring trip out west, fossil hunting, spending time at our Wyoming ranch, rock hounding, you name it. But I'm back and I'm ready to tackle some projects that have been sitting around for a while and really need to get done. And I think you're going to find them interesting. Speaking of interesting, though, if you're all interested in fossil hunting, rock hounding, um, just my Western videos, you can check them out over on my other channel, Mike's Lapidarian Fossils. Give that a look. I think you'll find some of those videos interesting if you're all interested in rock hounding or fossil hunting. So, what have I got for you today? Well, a little while before I left on this trip, a fellow in Taiwan, Joven, and I hope I'm pronouncing your name correctly. I really do, because we got a little bit of a language barrier between us. He sent me an email, and well, there was some Google Translate involved and a little back and forth. I speak zero Chinese, okay? And his English is, well, it's better than my Chinese. I'll put it that way. But it was a little back and forth before I think we understood each other. And he said that he has some e waste here, some scrap from an electronics plant in Taiwan, that he thinks is just absolutely loaded with palladium. And he was asking if he could send me some of it. And in return, all I have to do is make a video on how to extract the palladium from this stuff so he can do it back home. And I'm like, okay, that'll work. So just before I left on my month-long trip, this box arrived. And I had no time to do anything with it. So now that I'm back, we're going to start working on this. So, what did Joven send me? Well, it looks like cutoffs from something. He sent me a couple bags of them. I'll kind of zoom in here in a second. It's pretty heavy, whatever it is. It looks like, I don't know, it's a circuit board. I really haven't had a chance to actually even look at this stuff because we were literally heading out the door when this stuff arrived. It's like flexible circuit board material with some sort of shiny metal plating on it. And it looks like cutoffs from edges. So, yeah. I have no idea exactly what this came from. He didn't really explain it very well, or at least not as well as I could understand. So, I guess what I need to do, we'll start off by weighing it and see how much of this stuff Joven sent me. Okay? So I'll get my scale going here. I don't know if you'll be able to read it. The lighting, as usual, is awful. I guess so. So let's see, we're in pounds. Yes, I know I'm weighing the bags. Somebody always chime in and tell me my weight's not valid because of the bags. Uh, Probably my friend Richard will do that. Okay, so we got a little over 4.5 pounds, 4.525, or 2.54 kilograms. Okay. So he said he was going to send me a couple kilos, so he sent me a little more than 2 kilos here. So okay, that's pretty cool. We can work with this. So first thing I think I need to do is figure out whether there actually is any palladium in this stuff. Like I said, there's a bit of a lost in translation between me and Joven, but he thinks there's palladium here. Now, he also said that he thought these had been gold plated at one time, and the gold plating has already been stripped off. Now, most things that would strip gold plating, I'm thinking would also strip palladium. So I don't know if there's really going to be any palladium left on these or not. So, yeah, I think first order of business is to see if we actually have any palladium here, and then work on an efficient method to remove it from these things if there is palladium. So we do a small scale test, and we'll see what we've got. So let me get set up for that, and I'll show you what I'm going to do. All right, so for my small scale test, let me see if I can get about 100 grams of this stuff. Probably have to put it in a taller beaker than this. Some of these things are pretty long, or cut them up, one or the other. Individually, they're very light. This material is quite thin, so 100 grams is going to take a lot of it, apparently. Huh. My goodness. Only up to 72. I should have started with a bigger beaker. All right, so that's, I think I will. Let me tear it here, and we'll go with a bigger beaker, because these just aren't fitting in this little beaker. So 92. 104. All right. And 102. 102 is close enough. I'm not going to fight with this scale. I hate this scale. And it pretty much wins every battle we get into. So I'm just going to go with it. 102 grams of this stuff. So if there's palladium in it, nitric acid should dissolve it. And then we can do a stannous chloride test and see if there's any color of palladium. So that's what I'm going to do. So let me get this in the fume hood, and we will treat it with some nitric acid and see what we get. Okay, I got our 100-gram test sample in the fume hood. Going to put some distilled water on it. Try and get everything under the water. Not easy. I probably need to cut these into shorter strips. I don't know. Turn the fume hood on. And we're going to put some nitric acid on it. This is my homemade nitric acid. I have a video on how I make my nitric acid. I'll put a link up here in the upper right. You can check that out if you like. It's pretty simple to make nitric acid. You need a little bit of equipment and a few chemicals, but it's not that hard. So I'm just going to sort of eyeball it a bit. Whoa, hey, we got us a reaction going on. Look at that. Put a watch glass on it. We'll let that go. Yeah, we're already getting some orange fumes in there. So the nitric acid's attacking something. There's clearly some kind of metal there that nitric acid can attack. So we'll let this cook for a while and see what happens. See if it gets rid of all that metal in there. If not, I may put a little more nitric acid. Yeah, we got a heck of a good reaction going on so far. That's a pretty potent nitric acid I made. It's better than the azeotrope. So, okay, so we'll just let that cook back up. Put a little heat to it. That should speed things up. And in the meantime, I'm going to make up a fresh batch of stannous chloride solution because I've been gone for a month. I don't trust my old stuff. And we will test it and see what we got. In fact, I'll put a link to how I make my stannous chloride solution in the upper right too, so you can check that video out if you like. Well, we had a pretty vigorous initial reaction in there, but it died down pretty quickly. There's not much going on right now. There is a little bit of bubbling. I don't know if that's showing up. There's still some bubbles rising in there, and it's not that hot, so it's not boiling. So there is still some kind of reaction going on, but it's pretty weak. And I'll tell you what, the liquid has turned a bright green. Okay, bright green. So what is that? Nickel? maybe? Are we dissolving off? Which I'm not really surprised. Nickel is an underplate on a lot of stuff that gets plated over with precious metals. So we might just be dissolving nickel. I don't know. Um, I know copper nitrate is blue, so I'll do a little research and see if nickel nitrate is green. But I'm going to put a little bit more nitric acid in here and see if this revives the reaction any. Yeah, the bubbling is a lot more vigorous. Okay. So we'll let this go a while longer. Oh yeah, much more vigorous. Okay, good. So we're going to let this go a little while longer because it looks like there's still a lot of that metal on these flexible strips, whatever that metal is. So see if we can dissolve away a little bit more of it. Get the concentration of whatever metal it is in the liquid up a little bit before we do a stannous chloride test on it. So we'll just let this cook for a while. Well, my goodness, I went away for 20 or 30 minutes to do other stuff, and well, we're still getting a pretty good reaction. I think maybe it's because it's heated up some more on the hot plate here. But look how dark green the color has gotten. Wow, that is really super dark green. And the more I see that, the more I'm thinking nickel. So I'm thinking there's some nickel in there. Maybe that's what that silvery metal on there was. Whether there's any palladium or not, well, that's yet to be determined. But I'll tell you what, this really dark green color, that may make it hard to tell with the stannous chloride test whether there's actually any palladium in there or not. But the reaction's still going. We're still getting fumes, even after, like I said, 20, 30 minutes. So I'm just going to let it continue to cook. And we'll deal with whatever we've got when the reaction subsides. So we got a bit of an interesting development here. I went away for lunch with some friends. Was gone for a couple hours. I just left it on low heat. Came back. The liquid has gone from deep green to deep blue. And there's some, I don't know if it's showing up, but there's some metal foils floating in there, silvery metal foils. And I think I know where the blue colors come from. Let me show you. So I probably should have done this at the beginning before jumping right into this, but I've cut up a couple of pieces and I've looked at them on the cut edge, which I don't know if there's any way I can get a photo of that. I might try, but it's pretty hard to see even with my loupe. This silvery metal, whatever it is plated on top of copper. And our initial reaction was removing this silvery metal, which looks like it is nickel. And then we've gotten down to the copper underneath, and the copper is going into solution now, and that's why the liquid has gone from green to blue. So yeah, I can see copper in there with my loupe on the edge when I cut it. So, okay, that makes sense. Now, a lot of times they'll plate a metal like nickel over copper because copper is a fairly soft metal, nickel's a lot harder. And according to Joven, these were gold plated at one time, and that makes sense. They'd plate gold over the nickel. But he says the gold was removed, and he's thinking there's palladium left. I don't know. I don't know. I'm thinking anything that would remove the gold would remove the palladium too. But we'll see. So there's a lot more metal in there to remove than I thought there was. So I'm just going to let that cook in the dilute nitric acid for a little while longer. If there is palladium there, I know it's not going to go into solution until all of the more reactive metals are in solution. The nickel, the copper, anything else that's in there that's more reactive than the palladium. And the palladium is going to be way down on the list of reactivity, down with gold and platinum. So I'm just going to let it cook. And so the mystery is, what are those floating foils in there? Are they palladium or are they nickel? I don't know. I guess we're just going to let it cook and see what happens. Alrighty, until I came over here and stirred this stuff, I had no idea just how many foils were in there. This thing is loaded with those silvery metal foils. Whatever they are not dissolving in the nitric acid solution. And I can now see areas of copper on the strips. I couldn't see that before. So, yeah, I don't know what's going on here. Joven, what have you sent me? I don't know. But yeah, if that's palladium, which I'm not 100% convinced it is, but if that's palladium floating in there, yeah, it probably won't start going into solution until after all the copper is in solution. It would just cement out again on copper and wind up floating as a foil again. So, what can we do? I don't know. I have to think about this. At this point, I'm open to suggestions from my audience. I think we probably got some nickel, some copper in here, and some other metal that is not dissolving readily in dilute nitric acid. I know aluminum doesn't, but I don't think that's aluminum. Could be wrong, but I don't think it's aluminum. Assuming it is palladium, well, I could stop the reaction before it goes to completion and separate the foils from the rest of the stuff and then try and dissolve the foils. That might make more sense. Or at the very least, skim some of the foils off and try to dissolve them, and then see if we get a clear palladium signal. That might be the easiest thing to do on a small scale. This is a small scale test after all. Let me see if I can skim some of these off and get them into another beaker and try dissolving them and see what happens. Yeah, I'm getting quite a bit skimming off the surface here. And I'm getting it relatively free of that blue-green stuff. So I think that's probably enough right there to tell me whether there's any palladium in it or not. So what I will do is put a little nitric acid on this stuff. And we'll see what happens. Huh. Put a little heat to it. Lid this stuff up. We'll let that stuff cook for a little while and do a stannous chloride test on it and see if there's any palladium there. Alrighty, it's been maybe a half hour, and I'm liking the color on that. That is the color of precious metal in solution. Doesn't mean that's what it is, that's just the color of it. And most of the solids I put in there have gone into solution. There is a little bit of black scum in there that hasn't, but a lot of that metal has dissolved in the nitric acid, the dilute nitric acid solution there. So I think it's about time to pull that out and do a stannous chloride test on it and see. I'm not sure that I can do a reliable stannous chloride test on this stuff since the liquid is so intensely colored. But this stuff, yeah, I'm pretty sure I can figure out whether the floating gungeon here is palladium. Well, I had a thought. It might be platinum. It might be platinum. So we'll see. Although, I don't know. I'm thinking most of the platinum wouldn't dissolve in nitric acid, but platinum is a very funny metal. It does weird things. So It's possible. We'll do a stannous chloride test on it and find out for sure. Enough speculation. Let's find out. Alrighty, so let's do a stannous chloride test on this very suggestively colored liquid here. Let's see what we've got. We'll put a little bit in this spot plate. I've got some very, very fresh stannous chloride solution here. Just made it. So let's see what happens here. Oh my. Did you see how orange it went? It went orange, and now it's going green. It's going green. I would say we've got some palladium here. Yes. So yes, Joven, it looks like there is some palladium in this stuff. All right. Oh yeah, it started out very orange and now it's very green. That looks to me like the signal for palladium. Oh, all right. Sorry if I doubted you, Joven. I think you said this stuff was gold plated. I don't know how they got the gold off without stripping the palladium too, but yeah, there is palladium there. All right, so next step is I got to figure out how to separate the palladium from the base metal efficiently. All right, I'll give that some thought. So I think it's pretty obvious at this point. There's nothing else I want to do with this. I got the heat turned off. Hopefully all the nitric acid in there is used up or about to get used up, dissolving the copper. And the palladium foils there are just going to be left behind. And I will endeavor to separate the palladium foils from the rest of this stuff. I'm going to let it all cool down because it's still hot, and probably tackle that tomorrow. And then once I've got the palladium foils separated, I can dissolve them separately. Or not. I don't know. Joven wanted a way to separate the palladium from this stuff. I'm not sure I want to dissolve it and then try to reprecipitate it. I have to think about that. And maybe do a little research in the good book, Hoke's Precious Metal Recycling book. Yeah. And see what the best way to get palladium back out of solution is. It's been a while since I've done that. I did that before when I processed my stock pot, which I can put a link to the series of videos I did with my stock pot in the upper right here. You can check that out. I got some palladium out of it after I got all the gold out. But it's been like a year or more, and I'm a little fuzzy on how to do that. I'll need to do a little research. But yeah, it looks like we've got a lot of palladium foil here. This is only 100 grams of the material. He sent me 2.5 kilos. There's a fair amount of palladium in this stuff. Wow. Just got to do some research, put my thinking cap on, and figure out the best way to separate the palladium from this stuff on the large scale for Joven. Okay, but for now, I'm just going to let this cool down. We'll deal with it tomorrow because it's blazing hot right now. Well, it's the next morning. I've had a good long think on this and done a little research, and I think I know what's going on in here. Let me show you something. So I think I know what I'm dealing with here now in Joven's strips. I think what we've got here is a sort of a sandwich of different materials. We've got some sort of substrate in the middle, some sort of plastic or, I don't know, composite material in the center. And then we've got a fairly thick layer of copper on top of that as a conductor. And then over the copper, I believe we've got a layer of nickel. And then over the top of the nickel, we've got palladium. So I think that's what we're dealing with, and it's on both sides. And I could be wrong about this, but I really think this is what we're dealing with here. Copper, plated over with nickel, plated over ultimately with palladium. So I put these in a beaker, and I put some dilute nitric acid on them, and we initially had a really strong reaction. I'm just going to sort of eyeball it a bit. Whoa, hey, we got us a reaction going on. Look at that. Put a watch glass on it. And I think that strong reaction was the nitric acid reacting with the nickel layer. Because if we look at our old friend up here, the reactivity series of metals, we can see that nickel up here is much higher on the series than copper or palladium, which is going to be down here somewhere, although it's not explicitly called out on this list. So the nitric acid is going to react with the most reactive metal first, nickel. So I think what it was doing was it was chewing its way through the nickel underneath the palladium and above the copper. And that was our initial strong reaction. And that's why the liquid turned such bright green. We were making nickel nitrate in there. And I'll tell you what, the liquid has turned a bright green. Okay, bright green. So, what is that? Nickel, maybe? And then later, as we started running out of nickel, the reaction slowed down because copper is less reactive than nickel, so we don't get quite as strong a reaction with the nitric acid. And we started seeing bits of shiny metal floating in the liquid, and that would have been the palladium layer coming off because there was no more nickel between it and the copper now. But the palladium wasn't going into solution because copper is more reactive than palladium, so the copper was reacting with the nitric acid. And any palladium that did go into solution would immediately cement back out on any copper that was available in there. So I think that's what happened. And fortunately, I didn't put so much nitric acid in there that the reaction went to completion and dissolved all the copper and then started dissolving the palladium. I think the copper layer is pretty thick, and it takes a lot of nitric acid to dissolve copper. So I think what happened is we only got partial dissolution of the copper layer, and basically none of the palladium, or at least very little of it, has gone into solution. So that's my best guess as to what's going on. Okay, so you're probably asking yourself, where does all that leave us with this stuff right here? Well, I think, yeah, look at all the stuff in there. Yeah, I think what I want to do is use a physical process rather than chemical process to separate the palladium from the waste material here. And you can still see some copper on there, on those strips, which is good. Copper present on the strips is keeping the palladium from going into solution. So, yeah, I'm going to use a physical process similar to what I use when I'm working with fingers, gold fingers, where I dissolve the underlying metal and then physically separate the gold from the waste material before refining the gold. So I think I'm going to try the same thing with this. The first step, though, is to pour off as much of this deeply blue-green liquid as I can without losing too much of the actual palladium. So I will set up for that. Let me see if I can get the stuff to sink with a spritz of water. It really doesn't want to sink. But I will pour this off through a filter so I don't lose the palladium. And then we'll work on separating the palladium flakes from the remaining bits of circuit board material. And I'm also thinking that, dissolving the palladium in nitric acid like I did over here, it was a good test for it to tell us whether we had palladium or not, but really this is not the way to refine palladium. I'd want to dissolve it in aqua regia. So if it comes to refining the palladium, I'll use aqua regia instead of nitric acid to put it in solution. So I'm thinking in the future, when I scale up this process and try to make it more repeatable, that's what I'll use. I'll use, if I refine the palladium, I don't know that I'm going to refine it. That's, a completely separate issue. Getting the palladium out of this stuff is one thing. Refining it is something else. So, Yeah, I was reading Hoke's book on palladium overnight, and yeah, I came to the conclusion I'd completely done it wrong here. It was a good test, but not the way to refine it. So anyway, let me get set up to get this blue-green liquid off of this stuff, and then we will move on to physically separating the palladium from the waste. All right, so my intention here is to filter this liquid off and catch any bits of palladium in this filter here. Now, Joven, if you're watching, I'm using a lab grade filter. You can probably just get by with coffee filters for this. I don't think you need anything special. So there are some floating bits of palladium in here, so we are going to try and catch them so they don't go to waste. Now this liquid, I could do a stannous chloride test on it, and I will probably do that later just to be sure. But it probably does not contain very much palladium in it because I still see copper, free copper in here. But whether I detect a trace of palladium in it or not with a stannous chloride test, this liquid is going to go into my stock pot. So if there is any palladium in it, that'll wind up in my stock pot rather than putting it in my waste bucket, okay? So let me get the bulk of this blue liquid off of here. I may give this stuff a rinse with water as well, and I'll probably use purified or distilled water so that we don't get any chlorine in here because there's a lot of nitrates in here, and I don't want to make any aqua regia because that would probably put some of the palladium in solution too. And once I have this stuff rinsed, we will move on to the main mechanical separation process. It's just going to take a while to get it all filtered through this funnel. Okay, so I've got the bulk of the blue liquid off of here, and I'll tell you what, in spite of my best efforts, a lot of the palladium flakes have wound up in the filter. So I'm gonna rinse this stuff with sort of a minimal amount of water here. You can really see the copper in there now. I hope that's showing up. And then we will move on. Yeah, there's more of the palladium coming over. I'm actually, I think, getting the bulk of it in this filter. My idea was to use another process to separate it, but it wants to float. I'm not sure why. Rather than sink to the bottom, I have much better luck with gold fingers. They sink to the bottom. All right. So I suppose another way to separate the palladium Joven would be to just keep rinsing this stuff with water and stirring it, and then pouring off the water, which contains a whole lot of the palladium. So that's one potential way of doing it. I seem to be getting a whole lot of it in this filter. What else am I getting in the filter, though? That's a good question. I see some dark colored debris. I wouldn't be surprised if there's a little bit of the copper that's flaked off of the substrates in there. So refining the palladium might be necessary before just, melting down what's in the filter here to make little ingots of palladium. I'm going to have to change out that beaker here shortly. But yeah, I see bits of copper in there. I see some dark stuff. I'm not sure what it is, along with the bright, shiny palladium flakes. So it's pretty well contaminated. I guess some sort of refining is going to be required. We may not get to that in this video, though. That's a little involved. Maybe the next video. Okay, there's a look at what's come through the filter. There's obviously a lot of palladium flakes in there, but obviously also a lot of other stuff. So yeah, my initial idea that this is not going to need refining is probably wrong. Gonna have to refine that stuff. Okay, let's do a quick stannous chloride test on this blue liquid that I have pulled off of the circuit board parts there. Let's put a little stannous chloride on it. Okay, now that was interesting. It initially went kind of orange, and then the colors faded out to a light green. Certainly not as strong as the indication we got before with the palladium that was dissolved in nitric acid. So there's probably traces of palladium in this stuff, not very much. But like I said, I'm going to put these liquids in my stock pot just so I don't throw away any precious metals. I will get them eventually. Okay, so I'm going to set this filtration aside, and we will work on recovering the rest of the palladium flakes that are down here amongst all these bits of circuit board stuff. So I will get set up for that. All right, so as I've said a couple times now, we're going to try using a physical separation technique to try and separate the palladium from the waste material in here. I've just got a bowl, a colander. Probably this would work better with a bigger bowl. Biggest one I can find right now. Dump these in here. Let me wash everything out of the beaker. And at this point, I am just using tap water. I am not concerned about chlorine anymore since I've gotten all of the blue liquid off of this stuff. Now I've got palladium on my fingers. Now this is a technique I have used, speaking of fingers, with gold fingers. And it works pretty well, but the gold seems to settle better than the palladium does. So I'll put a link in the upper right to Gold Fingers video I did recently. Get all the little bits of palladium out of there. I'm going to put some extra water in here in the colander. And then I'm going to agitate this. And the idea is that the little bits of palladium will go through the holes in the colander, but the waste material won't. As I said, it works pretty well with gold fingers. See how well it works with palladium. Oh yeah, we're getting a lot of little bits of palladium in there, so that's working. Maybe not quite as efficiently as with the gold, but it's working. And we can just wash these bits of circuit board material and make sure we get as much of the palladium out of it as we can. We may miss a little bit. That's kind of unavoidable, unfortunately. And I think the amount we miss is going to be pretty minimal compared to the amount we capture, because I'm not seeing, I see a little bit in places. I think probably this stuff could have cooked in nitric acid a little bit longer, because I do see a few places where there's still some palladium stuck on them. But it's kind of a delicate balancing act, getting the right amount of nitric acid in there to dissolve the nickel undercoat and some of the copper without dissolving the palladium. It's a delicate balancing act. So I think I got lucky on my first attempt at this. So Joven, feel free to experiment. Let me pull these out. Yeah, I would say we got the bulk of the palladium. There might be just a little bit here and there. We got the bulk of it. Between what's in this filter back here, or the first filtration, and what's in here, we definitely got the bulk of the palladium. And so far, the only chemical we've used is nitric acid. Might be able to do it with poor man's nitric, basically just sulfuric acid and a nitrate salt, if you have trouble getting hold of nitric acid, Joven. So that's a possibility too. Get all the little bits of palladium off of my colander. Okay, into the bowl here. And there's a lot of stuff down the bottom of the bowl. I'm going to do the same thing I did with the other stuff. I'm going to pour this liquid off through a filter. We're going to catch all those little bits, and we'll have two filters containing pretty much all of the palladium from 100 grams of this material you sent me. So let me clean up my mess a little bit and get set up, and we'll filter this stuff. Okay, we got pretty much the same setup going on as before. Just going to pour this liquid off through this filter, capture all the palladium, and again, this can probably just be a coffee filter. I don't see any reason why it can't be. And then we'll have all the palladium on two filters. This is the first filter. This will be the second filter. And then once we have the palladium separated, we can decide what we want to do with it. All right, so this is going to take a little while. I'll be back when it's done. Okay, so I've got the bulk of the liquid has gone through. It's over here and in here. I've got the last little bit in here that contains the bulk of the solids. I'm going to put this in. I do it this way just to keep the solids from clogging up the filter and making filtration take forever. So there we are. So I will just let this stuff run through. And then we will finally have all of our palladium captured. And I'll be back when that's done. And we'll talk about some stuff and where to go from here. Alrighty, so here's our two filters in here that contain all the palladium from what was originally 100 grams of the stuff that Joven sent me. I don't know if I mentioned earlier, this liquid over here, I'm just going to put in my waste bucket. I don't think that there's enough trace palladium in it to bother with putting it in my stock pot. Besides, my stock pot's pretty full right now. This has been diluted a lot with rinse water, and there wasn't much in straight liquid, so probably not worth putting in a stock pot. If we take a look at the leftovers here, I hope it's showing up. There is a little bit of palladium still here. Not much. I think we got the bulk of it. Just in a few spots. A little bit. There's a little bit. Some of this might even rinse off if I was to try rinsing it again. Yeah, it's pretty loose. So we got the bulk of it. There's some more that's stuck on right there. So I would say we got 99.9% of the palladium out of this stuff. So I think I got pretty lucky my first time out the gate with this material, Joven. So, I mean, is this the only way to process this stuff? Probably not. Is this the best way to do it? Maybe not. Is this a way to do it? Yes, obviously. We've got all the palladium off of it, well, most of it, in the filters here, okay? So I think that worked pretty well, considering. So I think in the next video, I'm going to try and refine this process, run a larger batch, and try a couple of things to try and get more of the palladium off, and see if I can make this sort of a repeatable process for you. I don't know. You didn't tell me how much of this material you have, whether you regularly get it or it was a one-time thing. So I don't know, Joven, if this is something you're going to have to do multiple times in the future or not. But I'll try and make a repeatable process for you in the next video. And then once we have enough palladium metal built up, well, then we'll go on to refining it and turning it into pure palladium, because this stuff is really contaminated with, well, all kinds of stuff. It looks like black and green bits from the substrate, copper. Um, there's probably some other stuff in here, and it probably still a little bit of nickel too has come across with it. So yeah, it's going to have to be refined. So we'll work on that in a future video too. But I hope this has helped give you some idea where you need to go with this, Joven. And thanks a lot for thinking of me, asking me to be a part of this project with you. I really appreciate it. And folks out there, if you've got a project you want to tackle that's a little beyond your abilities, hey, don't hesitate to contact me and see if there's any help I can give you. I can give you advice. I can do like I'm doing with Joven and try and put together a process for you. I mean, I can't guarantee it's something I'll be interested in, able to do, or have the time to do, but it doesn't hurt to ask. It might come together. So keep me in mind if you've got a process that you need help with out there. I'll put my email address up in this video right now, and you can always contact me directly that way or via a comment in one of my videos. So, okay, subscribe to see my future videos of dealing with Joven stuff, and lots of other stuff I've got coming down the pike too. Hey, I'm back, and I've got a backlog of projects, so they're going to be coming fast and furious. So subscribe to see those future videos. If you found this video at all interesting, educational, informed, inspirational, whatever, give it a like, give it a thumbs up, and I'll see you in the next video. Thanks a lot for watching this one. Bye.